Hi guys, in today's video, I'm going to explain you solid design principles in very layman language. This is going to be a multi-part series. Okay, let's begin with part 1. You can think of solid design principle as basic building blocks for writing good code. Okay, so what does good code means? A code which is readable, maintainable and testable can be called as a good code. Okay, so back in college days, I read a very beautiful line. The only constant thing in life is change. Okay. You cannot avoid it. Okay. So if changes cannot be avoided, right, but you can design for them. You can design a piece of software which can, easily incorporate those changes because the changes are inevitable, right? How? So that's where the solid design principles comes into picture. Writing it today, but for tomorrow. Okay. So what does that mean? So any piece of code which you are writing today, right, will go into production sometime in future. Okay, and there will be then end users working on that code, so it is very likely it might encounter some bugs. Okay, or there will be some feedback from the user, or the user might provide some enhancement to you. So our code should be such that it could easily incorporate all these bugs, feedback or enhancements. So that is the goal which we try to achieve with the help of solid design principles. We try to write loosely coupled, easily extendable and modular code so that any foreseeable changes can easily be incorporated into our existing piece of code. So as a result, so once we apply solid design principles, we achieve readable, testable and maintainable code, right? So what does that loosely coupled or extendable code, modular code means? Okay, so in an enterprise application, it is much more than a code which you write in an interview, right? Your piece of code will be communicating with various modules within an application, or it is also possible that your application talking with different other applications which are available in the enterprise. Okay, so loosely coupled means your classes. So, say for example, there is a class C1 and C2 and C3 and so on, right? So there could be multiple classes in an application, right? So those classes should be loosely coupled that changes in one class should not impact another class. Okay, so say for example, you have received a enhancement which was supposed to be done and that is impacting class C3. So if it is loosely coupled, that there shouldn't be a ripple effect that changing C3 now requires change in C2 and C2 requires a change in C1. So that ripple effect should be avoided. And how do we do that? Once we write loosely coupled code, like classes are not dependent on each other. Okay. So what does extendable code means? So extendable code means, say for example, you have received some another enhancement, right? So which is supposed to be built on top of C3 class. Okay. So our C3 class should be repurposed or reused to write C5 class, which is an enhancement, right? Leveraging the existing code and building something on top of it. So that is called extendable code. Modular code is again that your piece or the application is divided into modules which are communicating with each other and they are, kind of independent of each other so that a change in one module is not impacting other module. So that is the end goal, and as a result, we receive this readable, testable, and maintainable code. We will talk about them in more detail in the subsequent videos. If you like my content, please follow and subscribe to the channel and do provide your feedback in the comment section. Thank you.